Hi, this is Professor Stugard, and in this video we are going to discuss classification. So our goals for this lecture are fairly simple. We just want to talk about what classification is, and we're going to talk about two methods of classification that we can use in data science to help classify or cluster our data. So what is classification? Classification is just our process of trying to group things according to their shared qualities or characteristics. Classification is an example of a problem that arises very frequently with data science and machine learning, where we want to create a model to solve some sort of problem for us. For example, our spam filters on our email. All of our email comes in, and then we have an algorithm decide, okay, which ones are junk and go to the spam folder, which ones are valid and go to the inbox, and it has to make this decision based upon properties of each individual email. And so there's an algorithm that runs behind the scenes that's deciding, okay, based on these different sets of criteria, is this spam or not? And it's classifying our email for us. Clustering is a type of classification, and so clustering or cluster analysis is the task where we want to group a set of objects in such a way that the objects in our same group, so our little groups, and we have a big set of objects, and we want to put them into little groups called clusters, and we want everything in an individual cluster to be very similar to each other, at least in some sense, right? Typically, when we look at these data sets, we've seen data sets with huge amounts of variables, so we need to pick some sort of criteria to make this cluster very similar to each other, which also means that we need to make the other clusters very different. So when we make all of our different clusters, each cluster should be very different from the other clusters, but each object inside of each cluster should be as similar as possible. So let's just take a quick look at an example in a way that we can do some cluster analysis kind of by hand first. So given this data set where I have ones and zeros and reds and blues and underlines and knots, how can I try to cluster the following data set? Well, what we want to really do when we do cluster analysis is try to come up with different groups and kind of work our way down through different levels of classification. So for example, I can ask this first question, is my element red? And then based upon the answer, yes or no, it gets classified into one of two different clusters. So I have a red cluster and a blue cluster. So I've taken my original data set and created two clusters, but I can always go a little bit further. Well, I can typically go a little bit further as well. So I asked, is it red? That was basically my first node. My first node now splits my data set into two clusters. And now I can ask another question. So for this data set on the left, I can now ask at a new node, is it a 1? And separate my data again. Now, by just asking these two questions, I've now created three clusters. I've taken my original data set and created three clusters for my data. Now, is that the only way I can cluster? Let's take a look. What if I asked a different question at the beginning? What if instead of asking if it was red, what if I asked, is it a 1? Well, now when I set up my first cluster, I have my ones on one side and all the zeros on the other side. I've created two completely different clusters at my very first node. Now again, I can ask further questions. I can ask, well, is it underlined? I didn't even ask that question in my first clustering sample, but I'm asking it now. Is it underlined? And again, that first group with the ones, that's all set. There's no way to further distinguish those, but that set on the right with the zero, sure, I can split that up. And now I have underlined and not underlined. So now I have three clusters again. But if you notice, these are slightly different. My clusters from attempt 1 and my clusters from attempt 2, again, they're definitely similar. And actually, we see the same cluster that showed up in both analyses. And if the same cluster shows up in multiple analyses, that's probably a very good cluster. That means that that group is definitely distinguished from the rest of the objects. That cluster has been fairly well defined. Now, the other two are definitely different. There's definitely some similarities, and hopefully we can see that, okay, there's definitely some parts that are similar, some parts that are different, but again, are my clusters exactly the same? No. Are they similar? Yeah. And what if I tried different types of clustering? Are those the only two ways I could have gone through clustering? And well, the answer is No, because we have 3 different variables, and I've been picking 2 at a time. So there's definitely other ways I could have done my clustering from the get-go. And that is part of what's called decision tree analysis. We basically take the data and we try to use a decision tree to split it into a bunch of different clusters. This is also sometimes called the random forest algorithm, where we would have our machine learning algorithm basically split the data into a bunch of different clusters and do a bunch of different cluster analyses over and over again. And at the end, look at the different clusters and see which ones are good clusters, which ones showed up a lot, which ones didn't show up, to hopefully discern some information about how we can classify things appropriately. But again, the main idea behind our decision tree algorithm is that at each node, each time we look at our sample, we ask, okay, what feature is going to allow me to split these observations in a way that makes the groups as different from each other as possible, and also make sure that the members of each group, of each cluster, are as similar to each other as possible. And again, there's not going to be just one way to do this. There's not just one way to classify. But it is an important idea when it comes to, again, trying to create different types of machine learning algorithms to sort our data for us. Now, when we do classification, in practice, we're basically trying to decide, does the element in question belong to a group, or does it not belong to that group? And again, we can typically simplify this as a very binary operation. Either 1, it belongs, or 0, it does not belong in the group. And what we can do is actually then consider this as kind of a probability problem, where we can take each individual element and assign it a probability between 0 and 1 about whether it belongs in that group or not. And then what we can do is set a threshold of probability that says, okay, well, on this side of the probability, if it's above this value, it's above my threshold, then we're going to put it in the group. And if it's below my threshold, I'm going to exclude it from the group. I'm not going to keep it there. The way we typically do this is with a logistic regression model. A logistic regression model can apply a probability between 0 and 1 to any binary event. And again, we classify it as pass, fail, include, exclude, true, false. Again, it's a very binary operation, 1s and 0s. And again, our logistic regression model allows us to apply that probability. So the logistic curve looks like this. All right, and the important thing to note here with the logistic curve is that the output is always between 0 and 1. So a logistic regression can only output numbers between 0 and 1. Now it's up to us to where we want to set the threshold. And again, we might have to, again, play around with it a lot to figure out what the appropriate threshold is. But again, the beauty of using my logistic regression is that, again, it's trapped between 0 and 1. Again, the further we go to the left, the more, the closer it is to 0. The further we go to the right, the closer it is to 1. And so basically, we're going to apply logistic regression. And we're going to do this mostly with just by plugging it into our algorithms, our programs that are already written in R. If you do want to eventually go on and develop much more sophisticated understanding of machine learning, which I do suggest, you will have to study more mathematics and understand how this curve works and how we use exponentials and stuff to define this logistic curve. But for now, again, just being able to use it is really all we're going to focus on in kind of our Introduction to Data Science course. So when we use the logistic regression curve, again, there's going to be multiple variables. There's going to be multiple inputs. So again, we have our observation. Our observation spans multiple variables. We take those variables, we input them all into our logistic regression model. And the logistic regression model is only going to output just one number, that one number between 0 and 1. And then, again, based on where we set our threshold, which, again, maybe our threshold is 0.5, maybe our threshold is 0.7, I don't know. It depends on the given scenario. Then, based on that probability, again, it's either sorted into include or exclude. And that's the basics of how a logistic regression model works. So, again, this is a big part of machine learning. A big part of machine learning is classification. We want to know what class or what group or what cluster an observation belongs to. And the ability to precisely classify observations is extremely valuable. In fact, it's one of the most valuable things out there. It's why people are collecting your data in everything that you do. It's why your cell phone tracks all of your movements, all of the websites you visit, every app you open. It even tracks who you're near using Bluetooth. right? Like the Apple AirDrop, right? You can just AirDrop pictures. Well, yeah, they're tracking who you are near at all times because that data is very valuable because they can input that data into their big machine learning algorithms and hopefully have outputs that tell them what you are likely or predicted to do. And again, sometimes it's as simple as going on, say, Amazon and seeing, oh, here's a list of suggested items for you to look at because the probability of you purchasing this is higher than other objects. It's also really important, like actuarial work, when trying to assign a loan. We can forecast, well, is this person going to default on the loan or not? That's a very valuable question for a bank before they give out the loan. And so again, data science gives us a plethora of classification algorithms. Again, we've talked about the decision trees and the logistic regression in this brief video, but there's also support vector machines, there's the naive Bayes classifier, there's a whole bunch of other classification systems. But again, we're going to stick with these two to begin with, and again, kind of talk about their concepts, and hopefully we understood what we were doing here with this different types of classification. But really, this is a huge part of doing data science and particularly machine learning. So, can you answer the following questions? First, are there only one way to cluster data using decision trees? And again, just think back to that example. Was there only one way to cluster our data, or are there multiple ways? And then the second idea, besides our decision tree algorithm, talking about our logistic regression, what are the options for the outputs of our logistic regression? And there's actually two parts to this answer, because the logistic regression is going to output one value, and then I'm basically giving you the answer, right? Once it outputs that one value, which is between what and what kind of value is it giving you? Then based upon our threshold, then it gets sorted into one or another, right? So again, hopefully keep those ideas in mind. We're going to start using logistic regression in our data science courses to hopefully create classification systems for our different types of models. All right. Well, I hope you guys enjoyed this video, and as always, take care of yourselves.